All right, so for our first example, you guys have this already on your paper, so you don't have to copy it down. But we got f of x is equal to negative x cubed minus 6x squared. So for our direction, it's asking us to state the end behavior. Then we have to find the values of the real zeros, including multiplicity. And then we're going to sketch the graph. So like I said earlier, nothing of today is really new. It's just we're going to put everything that we've learned so far into one lesson. Okay? So to find the end behavior, this is what we did for like the second lesson. So finding the end behavior was lesson 3-2. We already know how to do that, right? So if I look at the leading coefficient here, that's a negative x cubed. So a negative x cubed, is that even or odd? That's an odd function. And the sign up front is negative, which means the right side goes to the negatives. It has to go down. And the odd means the left has to go in opposite directions. Instead of down, it's going to go up. So my end behavior, we're going to write it as x approaches. The right side is positive infinity. Y approaches down, that's our negative infinity. And as x approaches the left is negative. Y approaches upwards is our positive infinity. Okay, so that's what we did for lesson 3-2. That was the very beginning. And then the next set of directions say to state the values of the real zeros. We did that for like lesson 3-2 and 3-3. We looked at that yesterday, also finding the real zeros. But we also found it in lesson 3-2 where we have to factor. The factoring part is lesson 3-3, and 3-2 is just finding the zeros. So let's go ahead and look at the function and see what we have. Notice I have a negative out front. You never want to have a negative there, so you for sure are going to want to factor out the negative. And I also have a cubed. And like I said earlier, you don't want really the cubed there. It either has to be like squared or to the fourth or to the first power. So in order to solve here, I want to check for GCF. So what do these two have in common? An x squared, but again, I also have the negative I want to get rid of. So I'm going to divide by negative x squared. And again, I'm dividing by the negative because I don't want the first term right here to be negative. So my GCF is going to be negative x squared. And then if I divide by negative, this is negative divided by negative. It's going to turn into a positive. And then x cubed divided by x squared, that's 3 minus 2. It's just going to leave us with 1x, x to the first. And then I can see negative divided by negative is going to be a positive 6. And then the x squareds are going to cancel. So it's just x plus 6. And I'm going to make that equal to 0 because I need to find the zeros. And then this is kind of what we did yesterday for lesson 3-3. In order to find the zeros, I need to make each piece equal to 0. So I got this negative x squared. Remember the x squared by itself tells you you're going to have a 0. So it's going to be 0. But the squared tells you you have multiplicity. Times 2. And then this x plus 6. You can show the work, but you can just skip it. But I'll show it for the first example. Remember, we make each piece equal to 0. So we subtract 6, and that gives us x is equal to negative 6. Okay? But again, you can skip this part. You don't even have to show me that. You can go straight to see x plus 6. This is going to just switch sign basically. So because that's positive, it's going to become a negative 6 for the 0. So I don't even need to see that work right there. You can just tell me that those are my 2 zeros there. Or 3 technically because of the multiplicity. Alright, so I did part A and I did part B. Now for part C, I need to sketch the graph. So this goes back to like lesson 3.1 and lesson 3.2. We're going to look at my steps over here. Step 1, remember, is to draw the scale. So on my x-axis, I'm going to go by 3. So 1, 2, 3, 4, 5, 6. And then go out to the negatives. Okay, so that's our step 1 for graphing, is to draw your scale. And then your step 2 is to plot the zeros. So figure out if I need a dot versus an asterisk. So dot, remember, is no multiplicity. And you put the asterisk if it has multiplicity. So for my 0, it has multiplicity, so I need an asterisk for the 0. And then negative 6 is no multiplicity, so we're going to put a dot. So at 0, put an asterisk. And then at negative 6, you're going to put a dot. I remember the dots means you cross the x-axis. And then in the asterisk, you don't cross. You like bounce off of the x-axis, creating a maximum or a minimum. Step 3 says to plot the end behavior. So my end behavior is over here. My right side has to go down. So I'm put an arrow pointing downwards. And then the left side goes up. So draw an arrow pointing upwards on the left side. And then we're going to start at the left, at the top. And then we're going to go downwards, cross the x-axis at the dot. And then go towards your next 0 by asterisk, so you bounce off of it, creating a relative maximum there. So this is my final graph. I don't know if you need to see that bigger, but we started at the left side upwards, you cross, and then don't cross, and end at the bottom. Okay? So again, we can see everything is not really anything new. Everything is kind of just all our different lessons combined into one. So let's go ahead and look at the next example. That was a binomial, so let's look now at a trinomial. So go ahead and copy this one. We have f of x equals x to the 4th minus 10x cubed plus 25x squared. All right, so we first want to find the end behavior. So for end behavior, I need to look at the leading coefficient. That's x to the 4th power. So x to the 4th, is that even or odd? Even. And positive or negative? Positive. So the right side has to go where? Up. And because it's even, the left has to go up. So for end behavior, we have as x approaches, the right is positive. Y approaches up is positive. I don't know what I said, but as x goes to the right is positive, y goes up to positive. And as x goes to the left is negative, y approaches up is positive. Okay, so that's my end behavior. Next, I need to factor. So notice for my function here, do they have a GCF? An x squared. I can divide everything by an x squared. So I'm going to put my x squared out front. And then x to the 4th divided by x squared, that's 4 minus 2 gives us 2. So that's x squared minus 10. X cubed divided by x squared, that's 3 minus 2 gives you x to the 1st plus 25. And x squared divided by x squared goes away. And then I have my trinomial. So remember, for trinomials, we look for blank plus blank and blank times blank. This is the same one that we had for prior knowledge. It was a negative 10 and a positive 25. So what are those two numbers there? Negative 5 and negative 5. So we had an x squared times x minus 5, x minus 5. And for prior knowledge, we wrote that as x minus 5 squared because you have two of those. The squared just reminds us that we have multiplicity. I forgot to put my equal 0 because we're finding the zeros. But when I do that, we're going to make each part equal to 0. So this x squared, remember that's x times x. So x equals 0, x equals 0. That means I got 0 with multiplicity times 2. And this x minus 5 squared, remember you just switched the sign. So that's a negative 5. It's going to become a positive 5. And then the squared right here tells you that you have multiplicity times 2. Okay, so I got my end behavior, I have my zeros. Next I have to graph it. So to graph, we follow the steps again. So step 1, draw your scale. So go from negative 6 to positive 6. Okay, and then figure out the zeros. Do I put a dot or asterisk? So I check to see they both have multiplicity. So that means I put an asterisk for 5, positive 5. And then I also put an asterisk at 0. The end behavior, it's the right goes up, the left goes up. So put an arrow upwards for both of those. And then we're going to make like a W shape. So don't cross on either of those. We're going to bounce and bounce, creating a W. And that's it. So again, this isn't really anything new. It's just we're taking everything and we're putting it together all into one lesson. Okay? All right. So how are you guys feeling? Good? Like, I have no idea what's going on in between. Okay. I see a lot of thumbs up, so that's good. So I want you guys to go ahead and try this one. We have negative x to the 4th minus 4x cubed plus a 5x squared. Okay, and you guys are trying this one. So again, you're looking for end behavior, you're finding the zeros, and then you're going to go plot it. So I was working up here for you in case you needed extra support. But this is right down, left down. So go ahead and write it, start partner. What is my end behavior here? So when we divide by a negative, all of your signs have to switch. So I'm taking out the negative x squared so that this first one could be positive. So negative divided by negative should be a positive x squared. And then negative divided by negative should give you a positive 4x. And then a positive divided by negative should give you a negative 5. So your two numbers right here should be a positive 4 and a negative 5. So what two numbers did you guys get for this part? 5 and negative 1. Because you want the 4 to be positive. That means you want the bigger number to be positive. Okay? And so for your two binomials, take out the negative x squared out front. And then remember that x squared splits in half here. So that's x and x. And then we have the plus 5 and the minus 1. And then if we solve for 0, we're going to basically make that equal to 0. The first piece, negative x squared, that's going to give us 0 with multiplicity times 2. And then the middle one, x plus 5, you just switch the sign. It's going to be negative 5. And then the last one, x minus 1, you switch the sign. It's going to be a positive 1. Okay? So we're going to put an asterisk at the 0, a dot at negative 5, and a dot at the positive 1. So let's draw our scale on the x-axis. And then to the negatives, I'm going to put an asterisk at 0, and then a dot at negative 5, and a dot at positive 1. And when you graph the end behavior, they both go down, right down, left down. So two arrows pointing downwards. And then we're going to cross at the dots and then bounce off on the asterisks. So we have cross, bounce, cross. And it looks kind of funky right there at the end, but it's fine. You got like a weird little dip right here, but that's fine. I'm trying to zoom in. So here you can see cross, bounce, and then cross. So you'll have a little funky looking hump right there. And remember, you can make your hilltops as big as you want. So technically I could have done even this and then go back and do this. As long as you're crossing where you're supposed to cross and your arrows are in the right spot. All right. I know that one was a practice problem. So I want to see like thumbs. How'd you do? Like you got it? I was stuck a little bit and I had no idea what was going on. So I kind of got it. I got it right, and I had no idea. Okay. So I see a lot of like in between, and I did see some thumbs up. I didn't really see any thumbs down, I don't think. So that's good at least. You have some idea. I think this one probably just messed up with the negatives and stuff. So I'm gonna have you guys copy this example. So you should be at the top of the next page now. We have a 2x cubed minus a 72x. So let's look at a binomial again. 2x cubed minus 72x. All right, so my first step is to look at the end behavior. So I got the 2x cubed is my leading coefficient. So 2x cubed, is that even or odd? Remember, you look at the exponent. So 3 is odd. And the sign in front of the 2 is positive. So my right side goes up, and odd means opposite, so the left goes down. So for end behavior, we have as x approaches the right is positive, y goes up to positive. That's a weird infinity. Let me rewrite that one. And as x approaches the left is negative, y approaches down is negative. All right. Then for my binomial, I need to look for a GCF. Do I have a GCF here? A 2x. Good. I can divide both of those by 2x. That's going to leave me with 2x divided by x squared minus 36. 72 divided by 2 gives us 36. Make that equal to 0. And then for binomials, remember you always want to check for dots. So do I have a difference of 2 squares here? Remember dots? Yes, good. The D for dots means subtracting the difference, right? And then you're looking for 2 squares. So I got x squared and 36 is a perfect square. That my perfect squares are 1, 4, 9, 16, 25, 36. So I do have a difference of 2 squares. So I want to do 2x times x plus 6, x minus 6. And then to find the zeros, you just make each piece equal to 0. So I got this 2x equals 0. If I do that, how do I solve for x? That's 2 times x. So the inverse is to divide by 2. That's going to give us a 0 there. And then for the other two, they're just going to switch sign. So this right here, x plus 6 is a positive 6, so I know I'm going to get a negative 6. But again, if you don't know how, that's x plus 6 equals 0, subtract 6. That's how we get the negative 6. And then again with the x minus 6 equals 0, that's just going to switch signs to be a positive 6. That's because we're adding 6. So x is 6. Okay? I'm just doing that step there just because if you don't understand where I got the zeros, that's where I'm getting them from. Okay? But I don't even need to see that work. That red, pink, and blue, I don't need to see that step. If you can do that mentally and you know that the zeros are going to be 0, negative 6, and positive 6, then that's awesome. You don't have to show this work here. Okay? So if you see a 2x divide by 2, that's going to give you 0. Right here, x plus 6, just switch the sign to negative 6. X minus 6, switch the sign to positive. So I don't even need to see this work right here. Okay? But this is kind of where yesterday's lesson comes in place too. Like, let's say you forgot that this was dots. You can do it like we did yesterday. So I'll show you really quick, just as a reminder of what we did yesterday. So I'm going to put or. You can do x squared minus 36 equals 0. You add 36 to each side. That gives you x squared equals 36. And then take the square root of each side. That's a plus and a minus. So x is going to be your negative 6 and your positive 6. Because 36, square root of 36 is 6. So if you forgot to check for dots, you can still solve it like this, like we did yesterday. Okay? All right, so I have my zeros. And I have my end behaviors. Now I can graph it. We're going to do our scale from negative 6 to positive 6. And then for my zeros, none of those have multiplicity, so it's just a regular dot at negative 6, 0, and positive 6. End behavior, the right side goes up and the left side goes down. So we're going to cross every time. So cross, cross, cross.
Isn't that multiplicity?
No, it's not multiplicity because it's not squared. It's only multiplicity if it's squared. All right, so let's go ahead and look at the last example for today. Let me skip over. I'm going to skip that one. Yeah, let's go ahead and try this one. I know it says practice, like technically you're supposed to do it, but I skipped the other one, so let's go ahead and just do this one. X to the fourth minus 29x squared plus 100. All right, so remember for end behavior, we look at the leading coefficient. That's x to the fourth. So is that even or odd? Even. And positive or negative? Positive. Which tells you the right side goes up, and because it's even, the left has to also go up. So as x approaches the right, positive, y approaches up to positive, and as x approaches the left is negative, y approaches up is positive. All right, and then this one's a trinomial, but do I have a GCF here? No GCF, so we're going to go straight to blank plus blank is negative 29, and blank times blank is 100. So figure out the factors of 100. You got 1 in 100, 2 in 50, 4 in 25, 5 in 20, and I think that's it. So out of all those, which one could give me the negative 29? 4 and 25. Good. But both negative. Negative 4 times negative 25 is positive 100. And negative 4 plus negative 25 gives you negative 29. So we're going to split our trinomial into two binomials. That's to the fourth, so split in half is x squared minus 4 and x squared minus 25 equals 0. So again, you can check for dots, but if you prefer doing it like we did yesterday, like adding 4, then taking the square root, adding 25, taking the square root, you can do that also. But for the purpose of this lesson, I think it's easier to just do dots. X squared minus 4 is going to give us x plus 2, x minus 2, because it's dots. So the square root of 4 is 2. And then the square root of 25 is 5. So I can do x plus 5, x minus 5. Make those equal to 0. So your zeros, just switch sign. This x plus 2 is positive, so switch the sign to negative 2, positive 2, negative 5, and positive 5. So for the scale, go all the way to positive 6 and negative 6. And we're going to put dots on all of those. So negative 2, positive 2, negative 5, and positive 5. And my arrows are both upwards. And we're going to cross every time. So cross, 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 cross. And that's it. All right, so you guys have the homework assignment to do. I think this is doable on your own because really nothing is really new. It's just review. So homework, you guys can work on that. 3, 4. Today's Tuesday, so it'll be due Thursday. Okay? So homework. homework. 3-4 is due Thursday.